Alright guys, we're going to take a look at our digestive wall models, the whole series of them here. We're going to begin over here with this model here. This is model A. This is the esophagus. So the lumen, the space where the food would sit here, and then we are looking at the progression through the wall as we move down towards the bottom of that model. We'll start off with the layers. We have our mucosa, the submucosa, the muscular layers, and again there's two different muscular layers. They're running perpendicular to one another. And then because we're in the esophagus, we actually are lacking a serosa. There's no serosa on the bottom, so there's actually only 3 layers to the alimentary canal here. I can tell right away that this is esophagus by looking at this mucosa and checking out the epithelium through here. And this is a stratified squamous epithelium. Bring that into focus here. And that stratified squamous epithelium is characteristic of the esophagus. The other thing that I notice are some of these purple glands, and these are mucus glands that are going to secrete mucus through a series of ducts up onto that epithelium to lubricate the esophagus so that we can move food through it. Okay, next up we have a junction point, a connection point between the esophagus and the stomach. So the left half over here is esophagus, the right half over here is stomach. I see the same things that I saw in the previous esophagus, the stratified squamous epithelium. I still see some mucus glands down in the submucosa. As I look over here at the stomach, and the mucosa, I notice some gastric glands, and the opening to those gastric glands would be called gastric pits. Here's my mucosa and my muscular layers. And notice now at the bottom of our model, we do have a serosa. That stomach does have a serosa. It's a simple squamous epithelium and then some connective tissue underneath of it. Our next model, model C, is full out stomach. We have our mucosa, submucosa, muscular layers, 1, 2, 3 layers within the stomach. We've got a longitudinal, a circular, and a transverse, and then we have a serosa on the outside of that stomach. Again, some gastric glands with gastric pits opening up to the surface of the stomach. Model D is a transitional model between stomach on the left and the small intestine, the duodenum, on the right. We'll do our layers again. We have the mucosa, the submucosa, the muscular layer, and then the serosa on the outside. I'm going to move to our next model now, model E. This is the duodenum, the first part of our small intestine. I can tell it's duodenum right away because we have these villi. I also see some Brunner's glands scattered throughout both my mucosa and my submucosa, and those Brunner's glands are going to be secreting a really alkaline mucus into the inside of the duodenum, which will help protect the duodenum against the acidic chyme that's entering from the stomach. I can also tell that this is duodenum by looking for that serosa, and I see that it is not present. The duodenum lacks the serosa. Moving on to F, I have some more small intestine. This is going to be either jejunum or ileum. Again, I can tell we're small intestine because we've got those villi, and those villi are really only going to be found within the small intestine. And I can tell it's jejunum or ileum because there is a serosa on it. The duodenum lacks a serosa, but both the jejunum and ileum have a serosa. I see some lymphatic tissue down here, and again, I see my muscular layers. Lastly, I have my large intestine in H. That large intestine has a nice smooth flat surface compared to the villi that we saw in the small intestine. And in our mucosal layer here, I see some glands. These are mucus glands, and that mucus is going to help lubricate the inside of the large intestine as well as hold all of the fecal matter together. So remember that our large intestine is where we're making those feces. So again, layers, I've got mucosa, submucosa, my muscular layers, and then a serosa located on the outside. Regardless of where we are within the alimentary canal, that mucosa is always going to have some sort of epithelium, and that epithelium tends to be either simple columnar simple columnar, simple columnar, simple columnar, simple columnar, simple columnar, or a stratified squamous as we get close to one of the openings. The reason for a stratified squamous in structures like the esophagus or the pharynx or the oral cavity is that there is a lot of mechanical abrasion that occurs there. So we want an epithelium that's thick and protective and that replicates quickly. So these cells close to the surface may slough off, but these other cells down deep are going to divide and sort of push the other cells forward. We use a simple columnar epithelium through the majority of our alimentary canal because it's really good at secreting things and it's really good at absorbing things, two things that are crazy important throughout the alimentary canal. The other thing that we can notice is our smooth muscle within the muscular layer. That's going to be smooth muscle almost anywhere in the alimentary canal with the exception of really the pharynx and oral cavity. And what else is common? Ooh, we'll do this one. The mucosa, or sorry, the submucosa. Submucosa here, submucosa here, submucosa here. Sometimes there are glands located within the submucosa, like our Brunner's glands or our mucus glands with the esophagus. But you're always going to see lots of loose connective tissue as well as some blood vessels scattered throughout that submucosal layer.